So from Pepperdine University, I'm going to turn it over to Tim Lucas.
Thank you. Thanks for inviting us to discuss slopes. I want to start by saying my goal is to give you a brief introduction to slopes, but really to give you an opportunity to play with the app and also to talk about what kinds of questions would be good to ask students as they explore differential equations with the app. And so I really want this to be more of a hands-on experience. So I'm anticipating that we'll have a lot of time to kind of explore with the app, and I won't spend an inordinate amount of time talking to give you guys that opportunity. So I put into the chat, and just in case anyone came in later, I'll just put it in the chat again, a link to my website, but also the direct links if you want to download slopes for either iOS or for Android. So it currently works for iPhone and iPad, and it works for Android phones. I'm not quite sure if it's going to be great on an Android tablet at this point. So that's something that you can download, anticipating an opportunity to play with the app.
So can I ask a question?
Yeah.
I'm watching you, but I'm also on my iPhone. What should I do without typing all of that stuff to get to the Slopes app on my iPhone?
So one thing you can do that's super easy right now, and I'll leave it up for a second, is you can just point your phone at the QR code, and that'll bring up my website, slopesapp.com, and there are 2 links on that website, if you like, that you can use right there. If that's not working at any time, I find that the keyword slopes differential equations, right, that brings up the app pretty quickly. If you just write slopes, you may end up with a skiing app coming up before you quite get to our app. But yes, you can go to you can just search on the stores, or you can slopes and differential equations, or you can go to our website slopesapp.com for those direct links. So I will just tell you about kind of how I approach the class when I'm teaching differential equations. I like to center all of our study of differential equations around mathematical models. So I like to start with students getting a sense of physical assumptions so that we can then translate those into mathematical expressions, so that we then understand why we're interested in possibly solving these differential equations. And then I think where slopes really comes in is where I talk to students about thinking about the differential equations before you just try to dive in and solve them. We all know that solutions are actually hard to come by, and really only come by in special cases. And so I try to get the students to look at things like equilibrium solutions whenever they're looking at an equation or a system, and then some sort of graphical analysis. Is that slope fields that they're looking at for a single equation, phase planes, numerical approximations. Those are the things that I try to emphasize before we get into techniques for finding analytical solutions. So that's why I think slopes ends up being a good tool for this class. I'll just tell you just very briefly that this app was developed with students at Pepperdine University. So they're programmed in the native languages for iOS and Android, and that's just so that the app works really, really well without having to have an internet connection, and also so that the computations are done right there on your device. So why do I want to use mobile devices like in the classroom for differential equations? Well, previously, when the iPads first came out, like we did a study of kind of how you could use iPads within the mathematical classroom, and we found that things like iPads and phones, they're very portable, but they have comparatively large screens, larger than traditional graphing calculators. but they also have these tactile interfaces where you can really kind of explore and graphs. And that led to a lot of collaboration amongst the students when sharing devices with each other, trying to share those pictures to interact with multiple students on one device possibly, or students looking at their own devices. So we found that using these devices led to collaboration and published something on that. And then we ended up I ended up developing slopes with students and brought that into the differential equations classroom, and did another study with my wife who does education research, and was able to kind of show how students were more engaged in the content, and we were able to develop a deeper understanding of those differential equations concepts. So okay, so that's all I want to talk about kind of to start, and then I want to, oops, just give me a second as I get myself to switch over to slopes. So I'm going to open up slopes for you really quick. And basically, I just want to show you a couple things about slopes to get you oriented to what kinds of activities are involved, but without going into too much detail so that you can then explore a little bit in breakout rooms. So slopes has 5 activities. There are things that you've probably seen before in various programs, whether it be Java applets or GeoGebra or maybe even Desmos, but you can open up slopes and you can, for single equations, plot slope fields. All the activities, you'll notice that when they come up, there's always an equation loaded and ready to go to play with, so that it's not something where you're having to enter something in before you can kind of start to imagine what's going on in the world of differential equations. You can enter your own equations in. So if you want to alter equations, you can do that. But you can also kind of choose from lists of preloaded models that are in there. Let's say you want to talk about logistic growth, you can select that, and that's available. Or you can even save your own. And what's nice is that you have these slope fields, you have the ability to kind of move around with your finger. You can add solutions just by tapping. You can go back to solutions and get them in a specific spot. Like I'm really interested in the equilibrium, maybe at 10, so I can edit it so it's right there on 10 in this case. You can kind of mess with parameters. So you can say, oh, what if I want to change a carrying capacity for a logistic equation? So I can kind of use sliders or use just kind of typing in input to change what the carrying capacity might be. So there's just a lot of places where you can play around with the equations and get a sense, not just of, okay, here's some solutions, but what happens as you change parameters? What happens when you're looking at different solutions from different time points. So we got slope fields, we have phase planes. This one always comes up with a predator-prey model, but it gives you 2 different pictures. It gives you a picture of what's going on in the phase plane with predators versus prey, but it also gives you a window where you can look at both of those solutions over time. And if you're working on the phone, there's some arrows at the bottom that allow you to move between graphs. So if some of the things that you see on the left on my iPad don't exist, you can kind of cycle through some menus using the arrows at the bottom so that you can get those features. And there's places where you can share what you've worked, the work that you've done. So you can actually do some sharing between devices, which is the share model. But you can export graphs and tables. And the students, I find, really like this because then when I ask them to make plots on their homework, they have a device that's easy to use to make plots, and they can add those plots to their homework assignments. So those are pretty standard tools that you've probably seen before, but you can also look at systems of equations. SIR pops up, which is quite relevant lately. But you can actually add equations, I think up to 12 or 15 equations. that you can add for a system. So you can do stuff with systems and equations and plot. There's stuff that has to do with second order equations. So you can solve second order constant coefficient equations, maybe homogeneous, maybe something that's non-homogeneous. It's a little easier to see when I take the velocity plot off there. So you can look at different, maybe a non-homogeneous system. And then finally, there's an activity that lets you understand a little bit about the numerical methods that are going on. And specifically, because this is not part of the activities that I have for people in breakout rooms, you can, I want to show you that you can kind of build solutions like using Euler's methods. So, or even more accurate methods. So you can say, oh, I'm going to look at how slopes might change as I move throughout the slope field. And then it's like, okay, that's one step of Euler's method. Oh, okay, so now this is, I'm building the next step of Euler's method, and I'm building the next step. And so it gives them a sense of like this, we're following slopes, right, in order to build solutions. You can even, with a little long press, solve the rest of this equation using Euler's method. So you can see that there's kind of 5 activities that are involved. What I'm going to do is I really want to spend the time like thinking about like how you would use this in your course. And so what I've done is, and I'm going to put this in the chat for people who are on their laptops, is I've made a Google Doc, and the Google Doc just has kind of stitched together some of the activities that I do in my class. So specifically, there's some activities that have to do with kind of a progression of population growth or exponential decay models. And so you can see how leading students through a progression, see how you kind of build up more and more complicated models, but also how you might think about using the slope fields in that discussion. And then I have some stuff about some systems that you can do stuff with phase planes, and then and even mass spring problems for oscillations. And so I believe that what I was going to do was break people up into breakout rooms so they could just have an opportunity to play with the app for about 20 minutes. And on the Google Doc, the idea is, this isn't homework. This is just an opportunity for kind of a starting discussion. And so you can look at, as a group, you can choose to look at kind of that first activity that's on it, or you can kind of breeze through different activities and just have a discussion about how you might want to use this in your classroom. And you can even critique my questions if you like, and say, oh, I think we could come up with better questions than the ones that I've proposed. But these are the kinds of activities that I do with students when we're kind of, each time we're introducing new topics. So what I'm going to do is, am I the one who's going to assign the breakout rooms? That was the one thing that, so this is just an opportunity for people to have a discussion. I figure we could talk for like 20 minutes and then we can come back and have a larger discussion. And I'm hoping I'll be able to roam through the rooms. So it looks like everyone's now back. And I didn't want to be rude to anyone, but I wanted to have time for questions. So I brought everyone back. I'm just going to say a couple words and then we'll take questions. When we ran the slopes study, like I think 2 kind of quotes that really stood out from the students are, it's good just because visualizing helps a lot to be able to understand, especially when you get to higher levels of math and things get kind of hard to understand sometimes. And then they said they really love how interactive the app is. You can move it all around and manipulate it. I like being able to click and see, okay, what does the solution with this initial condition look like? And that kind of feedback was the stuff that people gave in focus groups with my wife when we were running the study. So I just always like to acknowledge the students who are involved in this project. So there were a lot of different students who were involved in this project, who worked, maybe a year or for several years with us. One of those students at the bottom is actually a high school student who worked with me on it as well.
Wow.
And then all the graphics were done by Dana Zerzolo, who did graphic design at Pepperdine as a professor. And then And then we have a professor of computer science who is also an advisor, Stan Warford. So I like to acknowledge them. And then someone asked about this picture. So here's the QR code if you want to share this with other people, because sometimes that's an easy way to get at that. I do have another app that only works for iPhone and iPad called Waves that does series solutions to heat and wave equation and stuff like that. So you're welcome to check that out as well. And then I just wanted to open it up for questions.
Elizabeth had a question about PDEs, Waves PDE app.
Yes, it's so that app, I'll just mention it. I guess I'm here, so I guess I could mention it. So the Waves app has 4 activities in it. One is for constructing Fourier series. And so you can put in a function and it'll plot a Fourier series for a function that's defined on a period. It also does diffusion, so you can like have a diffusion equation and you can like look at how that evolves over time. And so it has a wave equation as well, and then it has one with like first order PDEs as well. So it's not quite, it has not been banged on as much as slopes. Slopes have been using for years. And so this one I've only really used in the classroom once, and we were still working out the bugs. So, but I think it mostly does really well. We just haven't had time to port that to Android. Okay. Question. I see a question with a hand. I guess people can.
I think that might be me. I was interested in the Slopes app. We were playing a little bit with the differential equation solvers, so with the Euler and the RK2 and RK4 routines. And I just wondering if you could bring that up and maybe talk a little bit about all that we're seeing there. There were some orange vectors, and I could tell it was something going on with the way the method was, but I just really was curious to hear what exactly you were thinking. See, I was getting that orange vector up there, and then in some of the RK, I could tell we were averaging some vectors, and that was something about what we were seeing, but I just wanted to hear what you had to say about that a little bit.
Yeah, so every time you get a new orange vector, it's like, this is my new step of Euler's method, and you can move it around and see how the slope changes, and then Tim, you just put it into place.
Tim, my orange on the Android, my orange vector does not move at all.
Oh, okay, good. You are the first one to encounter that bug. Yeah. That is, I have to say, that was the last activity that we redeveloped for Android last summer. So I will have to look into it. I don't own an Android device, so I have to say, but I have students who have Android devices, and I will work with them tomorrow on that maybe. But I apologize for that, but I will tell you, you can kind of build the solution one by one. But if you switch to the RK2 method, what you're seeing is you can see those 2 black vectors, and those are the 2 slopes that you would be averaging in order to do a second order Runge-Kutta method. So it's using the slope at the beginning of the time step, and then the predicted slope at the end of the time step. And so you can show the students like, oh, when I'm doing this time step, like I'm actually averaging 2 slopes, one at the beginning, one at the end of the time step. And so that's what that's for. Of course, for fourth order, you're actually averaging 4 slopes. And the middle 2 are longer because you're using you're using a weighted average, right? For the fourth order one. So this is just supposed to be a visual aid for people. Okay, I just saw another question from Nathan.
I just have a quick question, because I don't really use iOS devices. I use a Windows Surface for most of my in-classroom work, note-taking, presentation and stuff. So obviously there's no Windows-based app for this, but I use BlueStacks to emulate Android. Do you have any idea whether it's like the level of compatibility with BlueStacks?
I have not tested. I know of BlueStacks, but I have not tested it. So, yeah.
Okay.
So,
all right. Thank you. Yeah,
interesting.
I guess I'll test it and point out if there are any issues.
That's interesting that people are having trouble moving the vectors on their phone.
It was also for me with my Android device. I couldn't move the vectors.
In our group, I think.
Yeah, nobody in our group with
Yeah.
Android devices.
Well,
so that'd
I
be-
will have to talk to people because I have not had any trouble, because it even says on the iPhone someone was having trouble, but I was not having trouble moving vectors for that activity. But you know, that's the life of software development. It's constantly doing that.
So if
Were there
I
more
did
questions?
get that vector to move after you, but it's a little buggy on whether it moves or not on my phone. Sometimes I
Yeah,
can touch it and it'll go, and sometimes it's just not doing anything.
Okay.
mine wasn't moving either, but then I, restarted the app and it's working now. So it's probably just, something to do with resources or something. So.
There's a question in the chat about whether they're restricted to mobile devices, and that's the case for now, is that they're on the mobile devices. I need to do my own little work because I think it's not a lot of work to get it to work on a Mac because of the way that they've changed the development. But I have to say, yeah, getting it into Windows is be a whole new ball game there. So I don't want to be over the time. But I'm willing to hang out here and answer more questions for people if they like.
How often and how do you start using this application?
So I generally start on the second day of class.
Okay.
Basically I give them a little bit of an overview after doing things with the syllabus. So I try to introduce, okay, what is a slope field? What is a differential equation? What does it mean to be a solution to a differential equation? And then day 2, for the rest of the week, we're exploring these kind of simple linear models.
Like the ones you gave us
yes,
at the Google Sheet. Okay.
Yeah, so that first part of that worksheet is what it's some of what we do for the whole first week of class. And I mix in solution methods and things with that as well, but it wasn't relevant in this case. And then whenever we start with new models, we want to just look at the pictures, I think is what we try to do. So
it's your go-to first thing.
Usually it happens to be the case, right? I just did second order equations with the students, and we went to that oscillations activity and we looked at like whether the solutions made sense to them and looked at how with the mass spring motion. I'm trying to get them, I just want them to have a lot of pictures to work with and not be shy about the visuals, because I think that it's interesting when you watch students just completely work on pencil and paper and never really think about what the picture is. And that's something I learned from just, from calculus, right? Look, teaching calculus, I'm always trying to get them to picture what's going on. And in that case, I get them to use Desmos quite a lot for that. And in this case, that's what we were going for.
Any other? Can I get a screen? Is it easy to, on a phone, to get a screen capture and send it to myself? Is that?
Yeah, so there are two things that you can do to send pictures. Let me just bring up my Zoom again because I stopped sharing for all of you. But they're basically, if you're in slopes, well, first of all, you can always take a picture of your screen. But if you're in slopes, you can use that arrow with in the box button. And then if you do export graph, if you choose image, it will save it to your camera roll. So that's on your device. If you choose PDF, then it'll give you like a bunch of options here of ways to share it. So often I will email. It's like, oh, here's this graph in slopes, and I can email it to somebody.
Okay.
Or myself, whatever works best. Norma had a question. And
then a student could incorporate that in reports and things. That's
right.
I had something, two things. Tim, one is to encourage you to continue to work on the partial differentials. app because it's really necessary. I just had to teach a course involving that, and it was very hard to find a tool that I could use, with a single thing, you know. The question I had also was, in developing this, it kind of has the feel of Desmos. What are the differences that you would point out for the user? What were you trying to do that wasn't available on other apps?
Yeah, so I used to have my students use the Java applets with pplane and dfield, and basically they worked well enough for a while. We were having trouble, of course, with Java after a while in terms of students being able to run things in Java. But also you couldn't move the screen with your fingers, right? You had to figure out, okay, what's the right window? You had to go in, figure out what the right window is. And so that was kind of the big thing about this, being able to kind of recenter everything with your fingers. And so that was kind of the advantage of this. And then in terms of something like Desmos, which I think is a wonderful tool, I wanted something that was focused. I thought, you know, Desmos is great as your general graphing calculator, and it's a wonderful calculus tool to use. And you can create slope fields in it if you're willing to essentially find one that somebody has developed. But this was the goal here was to make something that was focused on the concepts that we have specifically in this class.
And one other question related to slope fields. For a few years now that or the last few times that I've taught, or several times that I've taught differential equations, even though it's not done by my colleagues, I really make a point of having them do the slope fields, you know, learn about them, learn about isoclines, which is what makes it easier for us to draw them. Of course, with this, you no longer really need the isoclines. Do you still spend any time? Because my students at least have a real hard time getting that idea. They end up just, somehow it's easier for them to go back to the one at a time. The isocline idea is complex for them.
I understand what you're talking about. That is a drawback in that I'm presenting these slope fields. There's not a tool to construct slope fields, maybe one by one, or like kind of draw your own slope field is not something that I have thought to do. Although I'm aware that this is something that they spend a lot of time on in the inquiry-oriented differential equations curriculum, right? I believe that they spend a lot of time on just understanding how to draw the slope fields. So I do have students draw slope fields on their own, you know, for homework questions, and really kind of understand, okay, what does each of these slopes mean? But I've taken a lot of the questions and reversed them with the students instead of like, now you need to construct a slope field. Instead, I'm asking questions about like, well, why are all of these slopes along, why are these slopes horizontally all the same, like in this particular graph, right? Why is it that there's only a vertical change and not a horizontal change? Like what's contributing to that? So I try to reverse questions because I've given them the slope field.
Yeah, I see.
So you should know that Norma is in Panama, and I think you've helped her out, and she'll spread that word around Panama.
Well, increase our Latin American downloads, right?
Yeah. No, for sure. I'll share it.
I can get them by region. I can get the downloads by region, and it's kind of fun to see.
Great. Now I have a face, Brian. I thought I was gonna hide it. Once I had 1 million, then I was gonna say, look, it's me. But now he'll be seeing, oh, Panama, they only have 2. She didn't do a very good job.
No, she's fine. So I want to thank Tim very much for what he's done and has been doing, and his colleagues. It obviously is not a one-person effort. and the fact that he's published articles in journals, and Primus, the journal that I founded, and so I'm pleased about that. But more importantly, looking at what he's doing from a reflective point of view and trying to do some formal assessment as to the values. But I think the most important thing is just getting the word out that this is here, and then people saying, wow, think about what I could do. And then, you know, like most of us are going to go offline later today or tomorrow and play with it, and we'll get more comfortable. And I suspect that you may have, and you might not even know it, you may have lots of people actually running workshops, teaching other people how to use your application, and you don't even know it, which is great, I guess. But because once you see what it can do, it's like, oh, wow. And my son played Algebra Arcade on an Apple II years ago. And all it was you give it a slope and an intercept, and you kill these little buggers on a line. And so he learned what slope and intercept were, but he never knew those words. So you can do a lot with very little here, and then enhance your learning when you know it as well. So I really appreciate your taking the time to be with us. And I think we all want to give you a thank you. And we will stay on, as Tim said, if you wish. Otherwise, we're coming back after dinner in rooms 1, 2, 3, 4, 5, and 6 for a whole bunch of different presentations of your choice. And have a good dinner. I see clapping hands. Thank you. Okay, anybody who's lingering has some questions. You said years. How many years?
We started in 2015.
Okay.
It was summer 2015. I started with two students, one who ended up transferring. So I only had one for a couple months, but yeah, it was 2015 was kind of the start point. And at the time I was not convinced. I didn't realize that you could do this on the phone. I kept thinking I need a bigger screen. So we only developed for the iPad, and then we had to go back and kind of reconfigure it for the iPhone. So that might have slowed us down a little bit. But yeah, so we started that. So I think the phone the iPad version came out in 2016, and then the phone version came out in 2017.
Okay.
And then Android was just last year.
Okay, yes. I mean, and that's because people asked you, right?
Right, of course. And basically in these sessions, and what I couldn't do is I couldn't get a student who was excited about developing for Android. And then and that's just kind of the nature of our students at Pepperdine. But then I did get one, and he was brilliant. And so that was just myself and him. That was it. Alex Krieger is his name. And the two of us worked on it, just the two of us for a year, redeveloping all the activities to put it on Android.
Well, it's certainly elegant and slick. And I see Boyan coming over from the other session here. I hope things went well for him there.
Oh, yes, it was great. Just
okay. Okay, thank you. So we have Slope Fields converts, and we have our studio converts. And that's good. This is a religious experience, you know, so. Well,
I know, I'm bummed. I wanted to learn some R, and I had to present.
Well, we'll put them up on the videos, and
I can give you the link to join the RStudio Cloud space where I posted all the materials.
Okay, well, you put it in chat right here.
Right now.
Yeah.
Okay.
Why not? And it's not coming, I see. Oh, you're finding it. Yes. Oh, there it is. What's a lot? Okay. So you can grab that in your chat, right?
Yes, you just click on the link and you can create a free RStudio Cloud account. It takes seconds. They just ask first name, last name, email, and then choose RStudio Cloud, and you can join the workspace that I shared. And I put 5 documents there, including the presentation, the source file, the Markdown document. And there is introduction to R, Markdown. I put our Primus paper on the topic as a supplement.
So that I wanted to go back to Tim.
Sure, I'm sorry.
And no, because both of you are advocates and have wonderful tools and technologies to use. And when I go to the site, for Tim, I was only wanted to download. I mean, I didn't want to explore. What else would I have at a site that you might have for, say, as a teacher saying, here's some ideas on how to use this?
Oh, sure. I didn't get a chance to mention that. It's on the Slopes app site. And I think I might put this Google Doc up as well. But on the Slopes app site, there's a tab that says resources. And I just have some PDFs of some of my activities.
Great.
And so those are all just sitting there. I have to say I'm not a web developer, so my website is very bare bones. It's just the Google site that the university will provide for me. But it does definitely have PDFs of my activities.
Great.
And if anyone was ever interested, I would be happy to pass along LaTeX and stuff like that too.
Okay. And the same for what Boyan is offering is up in the cloud as well. Are there ways for people to communicate with each other who are using like our fields? I assume there's a community that Boyan's trying to create, right?
Oh no, this is just a computational platform. This is just a cloud-based. This is just a cloud-based version of RStudio. But I have an instructor account that allows me to create share spaces, virtual classrooms, where I can share projects with my students and I can see what they do.
Gotcha.
And
for Tim, people who want to swap stuff about, I did this with it, I did that, where can they, or is there a place yet for that?
Well, that's something I need to be working on.
No, I'm not pressuring you. I'm just asking.
No. I mean, and I believe, there was some discussion, right, that we had about maybe setting up a space at Cubes, right?
Yes.
And I think that's what I want to do. And it's another one of these, it's actually a student project that I really kind of want to work on, because I would love to create kind of a database of examples or something that we could all kind of contribute to, and have a way for you to use Slopes to input to the database, right? Say like, look at this cool picture I made, or look at this cool model that I'm, and some little brief explanation about it. That I think that would be kind of a fun thing to do. But I haven't, it's kind of my next piece, right?
How many things can you juggle, right?
Well, I'm so fortunate that a year from now, I'm going to have a sabbatical, and I'm definitely going to use that time to expand upon just kind of the educational materials around Slopes. And of course the community aspect of it too.
That's noble, because people are saying, ooh, wow. And then they're saying, I could do this. And there's someone else in another room going, I never thought of doing that. And that's the exchange would be good. And Cubes is a good place. We're moving all of Symbiote there. I mean, so I encourage that. So, okay, if we're done, I'm going to leave, because I've got to get some din and then do something before 7. Thank you very much, Tim.
Thank you to everyone
for your session.